Hi, and welcome to this video, which is the final one in the set on using numerical methods to find roots of equations. And in this video, we're looking at how we might put all that technique we've been talking about in previous videos into a contextual question. So here we go. So we're solving problems in context, and it's either be iteration or Newton-Raphson will be the method we're using. Okay, so here we go. We've got the infection rate of initial vector of bovine malignant catarrhal fever. That sounds like fun in a herd of wildebeest. Okay, so we've got a modelling function here over time, and you can see we've got the number of infections as modelled by our curve here, and the equation for that curve is f of t is 10 over 9t sine t over 3 plus 1/10 t. And we've got a whole bunch of questions to answer there. So that's the setup. It's essentially the same as we've done previously in terms of just finding different points on curves, but doing it using numerical methods and relating it back to a context. So we've got three parts of the question. Let's have a go at the first part. It says find to the nearest day how long the outbreak lasts. So the outbreak is over when f of t equals 0, so that would be that point there. And so we've got to just put that equal to 0, so this is not a numerical methods thing, this is just can we go about solving that equation. And we'll go about it by first of all taking out a value of t, and you can see straight away if we factorise it that we're going to get a t equals 0 from there, which would be that point. We're going to need when that one equals 0. So let's do some solving. So we end up with sine t over 3 equals minus 9 over 100. And so sine to the minus 1 of that gives us a negative value initially. Well, that one's no use to us because we want that time, so we don't want that one. That's the value that we're going to be looking for, 3.23. Let's get rid of the negative one. And now simply we just need to do the times by 3, and that gives us 9.6951. Now, the question says find to the nearest day, and in the question, if you look back, it says that t is defined in terms of weeks. So what we're going to do now is just take that number of weeks, times it by 7, and there we go, we've got it to the nearest day, which would be 68 days. And there you go. So the first bit, just a bit of straightforward equation solving and trig. On we go. It says show the highest number of cases of BMCF, bovine, catarrhal, whatever the thing was, occurs in the 7th week. So what we're looking to do clearly is prove that this maximum here is occurring in week 7. So if we're looking to prove a maximum, we know we need to prove that f-t equals 0 when our maximum occurs. So let's do some differentiating. So there's our original function. So let's do the differentiating. We've got a bit of product rule to do in here. So differentiate one, leave the other alone. Plus leave the first one alone, differentiate the second one. So our sine has become the cos, and we've got the extra kind of dividing by 1/3 coming out into here. And then what we've got then is just differentiating the 1/10 t. That's a nice straightforward job. Now we're dealing with time, so we've got to prove it's happening in the 7th week. Now if we think about what's going on, our 7th week, week 7, is that one there. Because let's just consider week 1. Week 1 goes between t equals 0 and t equals 1. So week 2 is going between week t equals 1 and t equals 2. So that means week 7 is going from t equals 6 to t equals 7. And what we've got to do is prove that the maximum is occurring in there. So this is actually going to become a change of sign method, because if we're trying to prove a maximum, we're going to try and prove where this thing here equals 0, where there's a root to this, where it equals 0. And so if we can prove change of sign, and let's have a look. There's f dash of 6 is 0.18. F dash of 7, let's hope that's negative. There it is. There's our change of sign. And it's continuous, so there's our statement to say, yes, we've got a root in that interval. And in particular, what we're talking about with this one as well is we're talking about gradient. So again, another way of thinking about this would say, well, the gradient is positive at the start of week 7 when t equals 6. The gradient is positive here. And then the gradient becomes negative by the end of that week. So it's gone from positive to negative, so our maximum must have occurred in week 7. And again, it's absolutely vital that you relate your conclusion back to the context we're talking about. So I'm very clearly saying that the maximum numbers of BMCF has occurred in week 7. Right, that's that bit sorted. So part B turned out to be just a change of sign deal. Let's have a look at part C. So we've got to use the iteration of Newton-Raphson, one iteration of Newton-Raphson to find the highest number of cases recorded in that week. So we've got our differentiated function. I've renamed it to avoid any confusion over kind of how many differentiations I've done. So there's our function that we had that we're going to prove that we need to find the value of t when that thing equals 0. So we're going to apply Newton-Raphson, so off we go, let's do some differentiating. So this first term here, that one's fairly straightforward, no problem there. Here we've got a bit of product rule going on, so that's that bit and that bit there. Again, remember differentiating cos gives you minus sign, hence we've got a change of sign there. Differentiate the 1/10, that's just going to disappear, so there you go, there's our complete differentiated function. Bit of tidying up, because we can tidy up kind of the number of kind of cos terms we've got here. So we've got 20 over 27 cos t over 3. And so if I say, well, let's take t0 equals 6 as my starting point and plug that in. So g of 6, that's going into here. In it goes. G dash of 6, that's going into there. And then put that all together, so t1 equals, there we go, 6 minus 0.18 over minus 0.98. And we end up with 6.18. So we now know the time at which the maximum or the highest number of cases occurs. So what we've got to do now is work out how many cases that is. And in order to do that, we've got to take our value for t and stick it back into our original function. So there we go, so we need f of 6.18, put it back into our original function, and there we go, we've got 6.679. And so that's how many cases it was. And as it turned out, again, going back to the question, we saw that the number of cases was given in terms of thousands, so we've just got to turn that into thousands, and there we go, it is 6,680 cases at its peak at that particular point in time, given to 3 significant figures. And there you go, there's our modelling problem all done and sorted.